Hello, algebra students. Today we're going to start our third method for solving systems of equations. And to be perfectly honest, this is my favorite one of the three. Graphing is a nice way to start with systems of equations because you get a visual and you know what's really happening there and you're looking for where the two lines cross. But graphing is not... Sorry for the bell. Graphing is not always practical. You're not always going to get nice whole number kind of answers or numbers that are small enough to fit on a graph. So the next way that we solved this was with substitution. Again, nice if it's easy to get one variable by itself. However, that's not always the case. The method that we're going to talk about today is called elimination, and you guys should know what the word elimination means. It means we're getting rid of something. So we're going to be using addition today. We're going to add two equations together so that one of the variables will be eliminated, so we can just focus on the other variable to begin the problem at least. This is, like I said, my favorite way of solving systems. Most of the time, if I have a choice, this is the way that I'm going to pick, but it totally depends on the situation for each of the problems. So as this name implies, we're going to be using addition. We're going to eliminate one of the variables. To use this method, you need to have one of the variables, either the x's or y's, have opposite coefficients. Remember, the coefficients are the numbers in front of the variables. So right now, I don't see numbers in front of any of these variables, and you guys know if that happens, I can always put a 1 there. That's great. But if I look at these x's right now, those are not opposite coefficients. They're exactly the same. It's a 1x and a 1x. Those are not opposites. That's not what I want. However, if I look at the y's, this is a negative 1y and a positive 1y. That's what we're looking at. Now, I'm going to go ahead and solve this problem so you can see what this is going to look like. Just watch this one. You don't have to write this down. I am going to add my two equations together. And again, if you want to put those ones in there, that is helpful. I'll do a keep, change right there. 1x plus 1x gives me 2x. But the negative 1y plus the positive 1y, because they have opposite coefficients, when I add them, they really go away. That's the elimination part. And then I'll do 1 plus 3 is 4. Well, this equation is easy to solve because it's just an x now. So x is 2. Once I know the x, that's going to be exactly the same as what I did for substitution. I have to substitute it back in to find my second variable, the y in this case. So I'm going to use this second equation simply because I'm looking for the y, and in the second equation, the y is a positive 1y. So instead of 1x, I'm just going to say that the x is 2 plus the y equals 3. Now again, you should be able to do that in your head, but showing the work gives me that y is equal to 1. Now I know my x and I know my y, so my ordered pair is going to be 2, 1. And just like the substitution, or the graphing for that matter, you can substitute back into the equations and make sure that that answer works, that it makes sense. So if I would take a look at these equations that I started with, if the x is 2 and the y is 1, 2 minus 1, yep, that's 1. And if the x is 2 and the y is 1 in the second equation, 2 plus 1 is 3. That works. So I would like you to be copying these examples down in your notebook today to keep things simple in terms of just starting this method. We will give you problems where one of the variables is already opposites every single time. So in number 1, again, I'm so sorry for the bells. In number 1, the x's are opposites. This is really a 1x and this is really a negative 1x. And when I add those, they do cancel each other out. That's our whole goal today. We want one of the variables to be eliminated. So when I add the other parts of the equations together, we have just one variable. So 3y plus 2y is 5y. And 17 plus 8 is 25. We can solve this. So the y is going to be 5. Now, I'm going to erase that part that I crossed off up here so that it's easier to see the actual equation. Now, I need to go back into one of the equations. It does not matter which one, and I have to be able to find the x. Now, since it doesn't matter, I'm going to pick the one that's easier. I know that the top equation, the 3 and the 17, are a little bit bigger than the numbers that I have in the second equation. However, since I'm looking for the x, and this is just a positive 1x right here, that's the equation I'm going to use. So I'll say x plus 3, and then instead of a y, I'll write in what the y is equal to. 3 plus 5 is, or 3 times 5 is 15. And then we'll get rid of the 15. So x is 2. So if I know the x and I know the y, I can write my ordered pair for my answer. This will be 2 and 5. And again, you can absolutely substitute back in there and make sure that that works. In example 2, if I go too fast, remember you can always pause this and try this on your own. In number 2, the y's are the opposites. Okay, I know that all the problems that we've had so far where we've got opposites, it's just a positive y and a negative y, or a positive x and a negative x. Sometimes we'll have other numbers in there as well. However, those y's are opposites right now. They're going to cancel each other out. So I have 2x plus 5x is 7x, and 5 plus 16 is 21. So we can solve for x, and x is going to be 3. Now, when I'm looking for the y, again, I'm going to erase this one that I drew through here to make it easier to see that that got canceled out. One of these equations has a negative y, and the other one has a positive y. If I'm looking for y, I want to use it where the y is going to be the easiest to find. So I would say 5 times, instead of x, I'm going to put in a 3, plus y equals 16. Well, that's just 15 plus y equals 16. And again, in your head, you should be able to decide 15 plus what number gives you 16. It's going to be 1. So my ordered pair would be 3, 1. Here's a problem now where we don't just have like 1x and negative 1x, for instance. The x's here are opposites. Some people do get confused at this point and they say, well, the y's are opposites also because one of them's a positive and one of them's a negative. But a positive 3 and a negative 1 are not opposites. They're different signs, yes, but not opposites. Opposites mean exactly the same number, but different signs. So the 2x and the negative 2x, those are opposites. When I add those two together, they would be 0, or they would be canceling each other out. For the y's, 3y plus a negative 1y would be 2y, and 10 minus 2 is 8. So we can solve this equation. The y is 4. When I'm looking for the x, I want to go where it's going to be the easiest to find the x. And I would say in the top equation, since it's a positive 2x, that's what I'm going to choose. So 2x plus 3, and then instead of the y, I'm going to put the 4 in there, equals 10. This is now just a regular equation you can solve. 2x plus 12 equals 10. So we would subtract our 12 and get the 2x equals negative 2. And x is going to be negative 1. So I've got my x, I've got my y. Please be careful when you write your ordered pair. Always the x first. Negative 1, 4. On this problem, right now you should be trying to decide which variable have the opposite coefficients. And in this problem, it's going to be the y's, because I have a positive 3y and a negative 3y, and they're going to go away when I add. So 4x plus a negative 1x is going to be 3x, and 6 plus 3 is going to be 9. So that means that the x is 3. Once I know what the x is, again, I need to find the y, And looking at these two equations, I prefer the top equation. Remember, you can use either equation, it doesn't matter. I prefer the top one just because the y coefficient is positive. That's the only advantage here. So I'm going to have 4, and then the x is 3, plus 3y equals 6. Well, 4 times 3 is 12. And then we would want to get rid of the 12. And divide by 3. So the y is -2. So that ordered pair would be 3, -2. Remember, it's not because we happen to find the 3 first, it's because the x always goes first in the ordered pair. If you're feeling pretty confident right now, you may want to pause the video and just try this problem on your own paper. See if you can get it to work out. Get me the whole ordered pair for your answer. If you're not quite there yet, let's do this one together. 5x and -5x, those are opposites. They're going to cancel out when I add. So 2y plus 3y is 5y. -28 plus a positive 8 would be -20. So then y is -4. Once I know what the y is, I just need to go back and find the x. Again, I really truly prefer my coefficient to be positive. But if you really want to use the one with the negative coefficient, go right ahead. There's nothing wrong with that. So I'm going to use this top equation and say 5x plus 2 times the y is -4 equals -28. 2 times a -4 is a -8. And then when I add the 8, that'll be a -20. So I've got 5x equals -20, which looks very familiar. So the x is going to be -4 as well. So this ordered pair is going to be -4, -4. If you got to that point and you're starting to think, it seems kind of weird that we got the same kind of work in both equations, check it. We just use that top equation. Let's use the second equation to check it. So -5 times a -4 plus 3 times a -4. I want to see, does that really equal 8? -5 times -4 is 20. 3 times a -4 is a -12. Yeah, that is 8. That ordered pair works. In number 6, again, if you're feeling confident, go ahead and pause it. Try this one on your own. If you want to do this together, this time my y's are going to be opposites. They're the ones that will cancel out. So 2x plus 3x is 5x. 8 plus a -13 is -5. So x is going to be -1. Now that I know what x is, I want to find the y. So using this equation, it's just because I happen to choose that one, 3 times a -1, because that's what the x is, plus 5y equals -13. So -3 plus 5y equals -13. We would add the 3. This is why we've been practicing solving equations recently. And then we'll divide by 5. So my ordered pair, x and then y, would be -1, -2. So the worksheet today, it's called worksheet 7-3. It's the addition method. Every one of the problems you're going to see today will have opposite coefficients. So one of the variables would go away automatically when you add your equations together. The answer key is in Schoology, and then when you're done with that and you checked it, make sure that you take the formative. If you have any questions, let me know.